Today I'm going to take a look at this ION Networks SA5600 series. On the front there's not too much. It's an activity light and power light, and on the back is where things get interesting. From what I can tell, this device is used to remotely dial into serial devices through an encrypted connection. Now on the back we've got two 100 base T Ethernet ports, some USB, and a serial console port. Although I think they use this for like external modems. It's labeled auxiliary, or perhaps for another host. I'm not sure. This has an analog modem, sensor connections, and a contact header connector. A screw terminal. So this thing can do external monitoring of a room. You can have it so there's like moisture sensors and stuff hooked up to this to trigger an alert. These, I believe, are just serial ports, the host ports. So what happens is you would connect via Ethernet to this device, and it would establish a connection via serial to whatever equipment you need to monitor or remotely administrate. And this has like guaranteed encryption and stuff, because serial connections usually aren't encrypted. So you can dial in through modem, I believe, or I think you can actually use this to connect to something that would accept a modem serial connection. So basically this is a secure encrypted way into your building in order to access plain devices like routers and stuff like that. Now this particular one does not work, and I know why. It has a little screw on the back. It's a very nice case, just nice steel. And it pops right off, nothing on the top. So on the inside, motherboard. It's an ITX VIA based motherboard. They're custom boards, which are actually USB, but we'll get into that in a bit. And the power supply. Now the power supply is a standard barrel jack 12 volt power supply on the back, and this is similar to like those Pico power units, except a lot bigger. And as you can see, all the caps are dead. So these are KZE series by Nippon Chemicon, and they're all crap. Because I'm curious about this particular device, I purchased from Digi-Key some 470 mic and 1500 mic caps. So I am going to first pull out this power supply. We'll take a quick look at it. Then I'm going to swap out all the caps. Caps on the motherboard look good. I don't know if anything else is broken on this thing, to be honest. I did try powering it up just with a straight ATX power supply, and it refused to power up properly, so there could be other problems. Here's the power supply outside. It's just held in with 2 screws, although there's space for 4. It just takes a standard 12 volt connection on this end and produces an ATX connection on this end. Based on the power supply model, the P3-80W, I'm going to go ahead and say this is probably 80 watts. It's made by Magris? I have no idea. I've never heard of them before. They apparently use dodgy caps. It's fairly simple in design. It's just, a couple switch mode regulators and whatnot to make your 12 volt, negative 12 volt, and it needs 5 volt and that kind of stuff. So I'm going to go ahead and take off these caps and put on new ones. Didn't take too long. These are all Nichicon caps. These are the KY series, and these are the these are Nichicon VZ series, and these are Nippon Chemicon KY series. So easy switch. The new ones are much taller, despite the fact that they're the same voltage rating and everything. Well, anyway, some more dead caps for the bucket of shame. What I did was pop off the little shield here covering up the ports they don't want you to see. So I have access to the VGA port. That way I can plug in my monitor and see if this thing works when it powers on. I also have my Safety glasses, because capacitors can pop. Okay, I've got everything hooked up except the power. This is just a Netgear 12 volt 5 amp power supply, which is what's recommended. I didn't actually check the polarity, but I'm sure it's fine. One little side note, one thing I started using when I start soldering is this guy from 3M. I don't remember the exact model number, but it's, you just look up like painting respirator or mask or whatever. And this has a set of organic filters and like a pre-filter on it. And I thought I'd give this a try when soldering, just because I really hate using a fan. One, I'm usually listening to music when I'm soldering, so a loud blower fan is just annoying as hell. And two, it just takes up a lot of space, and I also do stuff like grinding metal with the Dremel, which this mask is designed for. I don't know if this thing actually blocks all the dangerous chemicals, but I can say that when I was soldering, I did not smell soldering at all through the entire time I was using it. So it's blocking something? I figure it's better than nothing, which is what I was using before. So time will tell if it kills me, but it seems to at least do something. So back to the task at hand. I'll get this monitor powered on, and let's see if this works. The power light blinked twice, which I cannot remember if that was what it was doing before. So it's possible it's still not working. There are a bunch of connections to the motherboard here. Oh yeah, I see. Yeah, it's blinking once in a while. So it is possible this board still doesn't work properly. Let's try disconnecting the ATX connector. And maybe I'll short the power. Oh no, okay, they're not even running. I think this is the power on. Oh no, it does go to the board. Okay, so they do have the power on signal running to the motherboard. Looks to be right here. Actually, we'll disconnect all of this and see what happens. See if this can just manually power it on. Where is a piece of metal? And we'll try and short the power wherever it is. Well, that's annoying. It just says front panel. It doesn't actually say which one the power switch is. So do not try this at home, kids. No, not getting anything. Well, that is certainly interesting. Give me a minute. I'm going to look up the information on this motherboard and figure out what the real pins are and see what we can do. So I hooked up my power supply tester, and I did actually find the right pin, and it doesn't do anything. And we're getting this. So something's not right with the power supply, which is weird because this is what it does when there's a dead cap. So the only thing I can think of is there's another piece right here that seems to be a small custom board here. Now this goes along to the power on switch. So let's open this up and see what's going on in here. Maybe there's a dead cap or something in there. If I can find my... Let's unplug the power supply for one. There we go. Here. Take this off. Now I know there's a little connector here. I can see it peeking through. Okay, so there's at least the little like JST connector or whatever these ones are called. And pretty tough heat shrink. Oh, there's actually stuff on this board. this might be a little microcontroller to handle the resetting. Oh, this isn't heat shrink, it's something with glue in it. With everything off, we can see what's on the board, and shockingly, it is a 555 timer. It must be sending a pulse every once in a while to the power supply, or the motherboard, to tell it to power on. Now, I am at a loss. Okay, so when this thing's hooked up, it's making a clicking sound, which is exactly what it does when there's a dead cap. These caps are brand new. It's not a dead cap. You know, we get the flashing light on this, so it's starting to power up and shutting down repeatedly. I tried disconnecting all the wiring and just shorting it, nothing happens. I tried disconnecting all the other boards, nothing happens. I tried hooking up a standard power supply, standard ATX power supply, to the motherboard, and it doesn't want to power on. So I don't know what's going on, because even when the motherboard's not hooked up, the power supply doesn't work, and the motherboard doesn't seem to work. It's possible the caps are dead on the board. I mean, they look okay, but who knows? They could be crappy. I don't have an ESR meter. So what I'm going to go ahead and do is take apart the rest of everything, and we'll take a look at it. I've taken everything out of the case. We've got just an input barrel jack going into the little 3-pin connector, although there's only 2 pins being used. That goes into the power supply, which I've got over here. I'll take the caps back off since they're most likely good. You know, no sense in wasting all the caps. I specifically bought them for this board. Yeah, I was kind of hoping it would work, but sadly no. Oh, and they have these nice little fuses on the input. Not bad. Not a bad power supply if it worked, you know. That power supply connects to this cable, which is a one of the like 22-pin ATX power supply connectors, or the smaller ones. It's got 2 small floppy drive style Molex connectors, and you've got this breakout style thing which has pin going to reset, I think. So this is what the board plugs into with the 555, and that sends signals to the motherboard. Down here we've got the other end, which is the same connector, but it also breaks off here for 2 standard Molex power connectors plus 1 more floppy. So that's the funky cable it's using. And if I can get everything disconnected. Alright, get that out of the way for now. Start to take a look at the board. Oh, before that, this is the front panel connector, or board. Hard drive LED, power LED, they're ridiculously bright blue LEDs. You can see that the case is actually made by Casetronic, and it's just rebranded, and it's got a power switch. The power switch is hidden on the actual case. I don't think there is actually a hole in the case. It's just covered up with the plastic, so you could like jam a pen in there. But yeah, they obviously don't want you turning it off ever. The other end is just standard connectors. This is actually kind of useful. I might hang on to this for testing boards, because you can just plug in to a motherboard and get all the information you need when you're working on a board. So that might be a little bit useful to hang on to. The first board is the, well, this is the top board, I should say, is the one with all the sensor relays and everything. This is actually a Diva Systems USB to I2C I/O board. And, well, I mean, it's the controller and everything, but they've you know, marketed it as an embedded controller, and even though it's a Cirrus Logic chipset, they just, you know, call it their own development board. And this is obviously a custom board made by ION Networks in 2005. They do have a header, space for a header here, but they aren't using it. It looks like it's just general purpose I/O. It doesn't look like it's actually doing anything special, but they've got the controller here, and it's just hooked up to the outputs here. These are two USB connections. It's fused, you know, pretty solid. It's got looks like there's space for LEDs here and a programming header. Over wired into the terminal block is an Analog Devices ADM211, which is a RS232 interface. It's a driver. I'm not really sure why it's hooked up to these, because these seem to just be like plain contact closures. So why is it RS232? I don't know. Could be running through here, but even then, these are appear to be the same thing, really. So I don't know what they're doing with it. This is a little E2 prom, and this teeny tiny little device here is a Texas Instruments A75240 transient suppressor for USB, and they've even got a poly fuse or whatever hooked up to it too. So they actually put some care into this. But that's the main controller. Cypress Easy USB. I think this is like their standard built-in USB microcontroller. I think they're really expensive too. I think they're like $10 a piece for some stupid reason too. But you know, saves you the $5 of using a damn FTDI interface, I guess. This is the host control board with the analog modem. This connection is a USB cable or connector that goes up to the other board that we saw already, and this is the USB connection to the motherboard. I have hooked these up to my computer using my little adapter to let me hook these guys up to a little regular USB, and that's how I figured out what the other thing is, the Diva Systems. And this one just shows up as the same thing on one connection, and on the other it's a dual FTDI RS232 to USB interface. Now, what's interesting is on this board, let me just get this wire disconnected and out of the way. That one doesn't have a ferrite, by the way. I don't know why the other one needs one, but that one doesn't. But the interesting thing about this board is that we've got these three data connections going over. These are all serial, standard RS232 serial, but you need 5. So you got your modem, which is going to take up one serial connection, and then you got 4 more. So, and this is a dual controller, okay? So we've got our 5 there. We've got 3, 4, 5. It seems kind of silly to me to have like some of them going through one interface and some through the other, but I guess it doesn't really matter. I mean, it just seems kind of dodgy, you know? But I mean, as far as the software is concerned, it shouldn't really matter. This over here, this modem, is actually a standard modem. It's made by Multitech, which I've actually taken apart their stuff before, a big modem server. And this is a standard part called a socket modem. And it's a 56K modem, and they use what they call a universal socket that lets you pop in cellular modems and all sorts of stuff, Bluetooth, and you just buy a new module from them and pop it in. So this is just a standard 56K modem. Nothing too special about it. They just put it in a special package that makes it so it's modular. And I noticed they have a fuse here. Apply heat shrink tubing to fuse 1. Well, okay. And they sure did. Here's the funky little fuse they're using on the analog modem. Kind of cool. Yeah. Interesting package. Maybe it can blow up. That's why they need the heat shrink tubing. But all we've got on this board is a FTDI USB interface. Screw you, FTDI. We've got a couple more analog devices, RS232 things, and that's it. Oh, and before I forget, this board actually does require one of the floppy drive power connectors. This is the PQI Discon module that they have installed. It's a parallel ATA unit, 128 megabytes, with a Molex power connector with a ferrite on it, of course, and it just connects to this little JST connector. Yeah, pretty standard. I've got a bunch of these. These things are kind of wacky to plug into a controller, so I'll have to read that some other day. This is the motherboard with the heat sinks off. This is EPIA PD by VIA, just one memory slot, and it's got the VIA Eden CPU, which is a low power x86 clone. This is the 6000, and I believe it runs at 600 megahertz, and it's pretty low voltage, 1.2 volts, decent, like, slow chip, similar to an Atom. And it's most likely the north and south bridge controllers, has onboard VGA, and obviously 3 serial ports, at least, well, 4, because it's got the external one as well. PCI slot, 2 parallel ATA, and front header pin I2C, and not too much else, you know, just your standard array. It does have onboard sound and stuff like that. It does make a decent router board. I mean, it is passively cooled. This is one of the 2 heat sinks. I like the cutout for the cap, and the one for the CPU. So, it's not a terrible board, but yeah, this particular one does not seem to want to start up at all. So, I don't know. Oh, and I figured out what this connector is for. This is a LVDS interface for a flat panel. But yeah, so I think I can just give up on this. It's not really worth the effort trying to figure out why the hell this thing won't boot. You know, it's not something I really need, and it's not really worth anything, even if it was working. These boards are generally fairly cheap, you know, like 20 bucks or so. So, oh well, it was kind of an interesting design, but unfortunately none of it worked. I really wanted to see what that thing would do. Like, if it ran a Linux or something where you'd have a command line access or anything like that. So that's a little disappointing. The system itself, if you can get a working one, it's a small case, it's a decent motherboard for like a router or something. So it's not bad. Like, I didn't pay too much money for it. You could always just pull out all the stuff that makes it the security thing. Like, you pull out the modem boards and everything and just use this as a motherboard.